In our last video, we ended up with x minus 3 squared plus y plus 1 squared equals to 18, right? So we know that our not turning point, our center is going to be positive 3 and minus 1, right? And then we know that our r is going to equal to the square root of the 18 over there. That is 8 square root of our 18. Great. So now let's look at 4.3.2. They want to know, do these two circles touch or not, right? The way that we are going to do this now, yes, there's more than one way to do this. You could possibly solve the two circles simultaneously. That would work. It's going to end up being a lot of work. Maybe we can do it in another video, but it's not the most efficient way to do a question like this, right? So what we are going to do is, okay, let's maybe just look at an example first before we get into any of the math. Let's try and understand logically what's happening. So let's say you have a circle here and another circle here, right? And you want to know if your circles touch, okay? You would do this. You'll find the center point here and you'll find the center point there. Then you will determine the distance from the one center to the other center. So that's the first thing you want to do. You want to determine the distance between your center of your circles, right? So maybe a random number, maybe this is 10, okay? The second thing that you are going to do is you are going to determine the radius of both circles. So maybe find this radius, maybe that one is 1, and you find the radius of this circle, maybe this one is 3. Okay, random numbers that I'm coming up with, right? So the distance between them was 10. The radii was 1 and 3. Okay, so if you add your two radiuses, your 1 plus your 3, you get 4, right? So when you summed up your radius, the sum of your radiuses was 4. The distance between the circles was 10. If the distance between the circles is greater than the sum of the radius, as you see in your picture over there, your circles don't touch. Okay, let's look at another example, right? The random stuff that we're coming up with now. Let's say we have two circles over here and we have the center of both of them. First thing we said was we're going to find the distance between the centers. So let's find the distance between them, and maybe that distance, okay, again, random numbers, maybe that distance is 5. Okay, and then after that you're going to find the radiuses of the circle. So maybe this radius is 1 and then this radius over here is 6. Okay, random numbers again. So if I add my radii, the sum of the radiuses, and I say the 6 plus the 1, and that gives me 7, and the distance between the centers was 5. Okay, so now the distance between the centers are smaller than the sum of the radiuses. My circles will touch, as you can see over there. Okay, and then maybe a last one would be if those two values actually end up being the same thing. Let's draw it also. Okay, let's say you have your two circles, right, and the distance from that center to the center is, maybe it's going to be like 6, right? And then this radius over here is 2 and this radius over there is 4. Okay, so now the sum of your radius is 6, sum of your radii is 6, and the distance between the midpoints is also 6. What does that then mean? That means that those two circles touch at one point. Okay, so you have these three scenarios. Either the distance between the midpoints and the sum of the radii are equal to each other, and if they are equal to each other, it touches one place. Or the distance between the circles, so the midpoints of the circles, is smaller than the sum of the radii, then it touches twice. Or your third option, the distance between the circles is greater than the sum of the radii, then it doesn't touch at all. Okay, so that's what the question wants us to find out, right? Do these two circles touch? So that's what we're going to do. Let's go find the center points first, right? The center of the first one was -1 and +2. Let's write that over here. -1, +2. That's my one center. My other center, I think that was 3 and -1. Let's write that as well. 3 and -1. Okay, so let's start by finding out the distance between our centers, right? So distance in a Cartesian plane, distance formula. Let's go with distance formula. So let's see, did they name these centers? The one center is A, the other center was M. So let's call it AM. Right, let's call it AM. So we're going to determine AM. Distance formula, that was the square root of x1 minus x2. This needs to be squared. There's a plus in the middle. Y1 minus y2. This must get squared. Right, that looks like the distance formula. Next thing, we'll do our substitutions. So we'll say x1. Maybe make it that one, so it's going to be minus 1. There's a minus in the formula, and then x2, let's make that 3. This needs to be squared, plus y1, so let's go with that. That's going to be 2 minus 1, and that must also be squared. All of this is under my root. Okay, so minus 1 minus 3 is going to give us minus 4. That's going to get squared. Plus minus minus, that's going to give you a 3, and that's going to get squared. Just go put all of this in a calculator, right? I don't have my calculator with me this very moment, so I'm doing it on my own. This is going to be 16 plus 9 is 25. So that's going to be 5 units, right? So no, I'm not going to say plus minus 5 because we're dealing with a distance. So it's only going to be positive 5. So distance between my centers is 5 units. Okay. The second thing that we said was we want to determine the sum of the radii. So let's go back quickly and let's go see what the radiuses are, radii are of my circles. That's the one. And the other one was this 25. Well, square root of 25. So the r is equal to 5 here. So the one is 5 and the other one is square root of 18. Square root of 18. So let's say r1 plus r2 is going to be 5 plus square root of 18. All right, let's get a calculator quickly. And that is 9,24, right? 9,24 units, right? Great. So what does this tell me? My sum of my radii is greater than the distance between the two midpoints. So we'll say therefore the two circles, we'll just write here two circles intersect twice. Right? Why do they intersect twice? Because the distance between the midpoints, right? So this thing over here, the distance between the midpoints is smaller than the sum of the radii. Great.